Good afternoon, everyone. It's so nice for you all to join us for our presentation today on the needle pressure transducer. My name's May.
I'm Kelly.
I'm Wong.
I'm Julia.
In today's presentation, we'll first introduce what a pressure transducer is, as well as how it works, and we'll briefly cover what a piezoresistive pressure sensor is, as well as a Wheatstone bridge. We'll continue to speak about the needle pressure transducer and how it operates, and we'll speak about the background behind that, including signal processing, the gold standard, previous methods, the motivation behind the device, its applications in the medical field, and the disadvantages and advantages of the device, and we'll end with our conclusion and references.
So we'll begin by introducing what a pressure transducer is. These devices are used to translate pressure into electrical analog signals. And most commonly, this is accomplished by using resistive or capacitive elements in the circuit. The most common application, of course, is to measure pressure in like tanks or compartments, and also in living systems. So the most common types of pressure transducers are resistive, capacitive, and now they're developing fiber optic pressure transducers. The fiber optic pressure transducer uses a mirror which is attached to the diaphragm of the transducer, and once a strain is applied to the diaphragm, the mirror changes position, and the displacement in light seen in the fiber optic cable is seen by an optical sensing element and output as a voltage potential. And in capacitive pressure transducers, a capacitor is in line with the diaphragm, and when strain is applied, the distance between the plates is changed, which changes the capacitance of the capacitor, which can be seen as a change in voltage. Now, Kelly will go on to describe the resistive pressure transducer and piezoresistive transducer.
Now we have the piezoresistive pressure sensor, which is widely used in biomedical applications, and it's the core to our bioinstrument. And the sensor itself consists of a diaphragm, which is built upon a silicone substrate that bends when there is an applied pressure. And an important thing to note about the silicone substrate used for the diaphragm is that as a pressure is applied, the resistance to a current passing through increases substantially, and what happens is it allows less current to pass through, and with less current that is passing through, less heat is generated, which allows our bioinstrument to be less heat sensitive, which Parker will go over during our disadvantages for the slides. And we have the Wheatstone bridge, which is used to sense small changes in resistances. In our case, the current that is passing through, when the applied pressure is, when it's applied on the sensor, and when the pressure is sensed, then there is less current passing through. And when the Wheatstone bridge can sense that there is there's a higher resistance and less current, then it will report that change as a pressure change when it's incorporated into our device.
One type of pressure transducer that we're going to be focusing on is the needle pressure transducer. As the name suggests, it has a needle, and the pressure sensor is embedded in at the tip of the needle. It has an operating system of piezoresistive effect. Like Kelly explained, it changes the resistivity of the semiconductor strain gauges, and it contains a Wheatstone bridge and a silicone diaphragm. So basically, this image right here is a basic circuit of a sensor. This dotted line is the silicone diaphragm, and these four are the piezoresistors, and it's all of those are attached in a Wheatstone bridge. So when the pressure is applied to the silicone diaphragm, it's going to go through some deformation, since it's connected to the piezoresistors, which acts as strain gauges. piezoresistors are also going to go through a deformation, which means it's going to change its resistivity. So the overall voltage output of the Wheatstone bridge is going to change. This device can be used in vivo. It is an invasive technique, but I would say it's like minimally invasive because the needle has a fine tip, so even though you poke yourself with it, it doesn't do much damage to your body. Basically, the measurement of this device is the pressure, and the sensor is the piezoresistor because the sensing part of the device measures the pressure by changing the resistivity. So signal processing is the transducer part of this unit, the device. The transducer, what it basically does is converting pressure into analog signal, electrical signals. So the output of the device, which is voltage, is the analog signal. So it has to be converted into a digital signal. So it has to be there has to be an analog to digital converter before it goes into the computer. So obviously the output display is the computer screen.
And some medical applications where the needle pressure transducer can be used would be to measure pressure present in the blood, eyes, bladder, and joints. And more specifically, we'll be focusing on the measurement or in between the invertebral discs. And this picture is just an example of showing the knee joint under, like, in its normal state and when it's affected by two different types of arthritis. And the bioinstrument, the needle pressure transducer, can be used to measure the pressure that is present in the fluid or the fluid surrounding the joint, and in the osteoarthritis, which is the middle picture, there's no space present, which I would assume would probably have more pressure.
So why is the needle pressure transducer so useful? Well, in the biomedical field, it's important to know stresses, strains, and pressures which the body experiences. This type of information is especially critical in designing durable prosthetics. So the needle pressure transducer can be used to measure pressure in joint surfaces. For example, in the intervertebral discs. Intervertebral discs are, they lie adjacent between vertebrae in the spine, and they separate vertebrae from one another. Intervertebral discs have three fundamental functions. One, they act as ligament and hold the vertebrae together. And two, they act as a shock pad and they absorb pressure, allowing for movement. And three, they act as a pivot, so that's what lets you like bend and twist. Everyday physical activity, along with injuries and daily stresses, causes degeneration, back injury, and so the needle pressure transducer, this is pretty important since it can allow for a way to determine loading conditions of the spine. It also lets you take pressure measurements, and it shows where in the spine these critical pressures occur and during what motion of the spine.